Hello class. The third part of our video will now we're going to look at how to handle the power calculations, right? So how are we going to handle the rest of the power calculations? So here, we're going to refer to these two pages. So we're going to have to hold on to these, okay? So you can't just throw them away and the problem's done, okay? One kind of depends on the other, okay? So part C, what we're going to look at is the following calculations. Part C we're going to look at is power factor, real power, and total power. Okay, and this becomes very, very simple. We're also going to analyze under power factor. We're going to look at lead, lag issues, and analyze the lead and lag and what that really means, right? So let's look at power factor. Our power factor. Our power factor is simply the cosine of the voltage, the angle of the voltage minus the angle of the current. Okay, so let's look at the angle of the voltage. Our angle of the voltage is given to us here and here. So here, 120 cosine omega t plus 10, or 120 at 10. So our theta v is 10. Okay, 10 minus. And what's our angle? Well, our angle of our current, if you look at this, right, the angle of our current was found to be on page 2. Our angle of our voltage is on, I just want to go on, is on page 1, which is here. Okay, angle of our current is on page 2, and our angle calculated to be here. If you want to review the angle of the current again, please review part 1 and part 2 of these videos. Anyway, it's minus 38.5. So when you write this out, it's minus 38.5, just like that, right? What does that yield? Our power factor now yields a cosine of 10 plus what? 38.5. The reason it's plus because minus and minus make something a plus, which gives us a value of what? So you take 10, just like here, plus 38.5, just like this, cosine 0.66. So our power factor is 0.66. That's not a very good power factor. Okay, 0.662, 0.66. I'll put 0.662. All right, it's not a very good power factor, but we'll go ahead and complete the problem. Okay, now what is our real power and total power? So the way we look at power. Okay. Oh, by the way, let me stop right here real quick. Okay, what is this lead or lag? How do I know if this is leading or lagging? I have to kind of know if something leads or lags. So how does that work? Well, when your current, when you have a current here, so let's just draw this current. Let's just draw this out. Okay, so let's draw out our voltage and current. So here, okay, here. Now, if I made a mistake, please feel free to correct me. I can, obviously we can, anyone can make errors, like this. So our voltage is crossing at what? Our voltage is crossing at 10. Just like that. Okay. Where's our current crossing at? Right? Our current has to cross somewhere. So our current at this point is crossing at minus 38.5. So here it's minus 38.5, which is here. Okay. And you're going backwards this way. So clearly, from this perspective, it's actually leading. Now, this is a very unusual system, but usually the current will lag. So our current will generally lag the voltage, but in this case, it's leading the voltage, right? So this is an exceptional case where we have a lead power factor, right? Because our power factor is going to be greater than 0. And because of that, but it's also an inductor, right? So go figure. So it's really an inductor circuit. Generally, a lead is a capacitor circuit, but in this special case, our lead is an inductor circuit, okay? Because it's so far out, right? It's so far out. So here our current leads our voltage, and we can still, but it's still an inductor no matter what. Now, and generally, if you didn't know, generally you assume capacitor. In this case, our current is basically assuming, our inductor assuming a capacitive what's the word I'm looking for? The inductor is assuming, is resembling something that's a capacitor, but even though it's not, right? And you have to review my calculations again to make sure that is the correct answer so that we understand the power factor calculation. Normally this would obviously be a positive number. But anyway, let's continue. Let's continue this problem and determine our real power. So we will do our power calculations and understanding what power is about. So power will give us P is equal to VM IM or VP IP times our power factor. Now this is our real power. This is our total power. Okay, and this looks a little weird, but if I make this look a little better there. And that's our power factor. So if we want our total power, I'm going to write total, right, is what? S. By the way, total power is also complex power. Okay? The same thing. So our S is now VM IM over 2. Okay? No power factor. Just here. Okay? So what the value is, how do I get the value? Well, the value is very simple. Our values are our magnitude. So what's our magnitude for voltage? Here. Okay? So that's 120. What's our magnitude for current? We already calculated the magnitude on page 2. We calculated the magnitude for current. Okay, so page 1, we have our voltage. Page 2, we have our current, which is 0.795 times 0.795. So S is equal to what? Divided by 2. So let's get that eraser. Change it up here a little bit. Okay. So our eraser is 120 times 0.795. Divide that by 2. We get 40. And I'm going to do this again because I want to make sure I get it right. 120. Divide that by 2. 47.7. 47.7 what? VA. VA, which is volt amps. Okay? Now, what is our real power? So we'll type in real power. Real power is also known as your average power. Okay? Your average power. So if I say P, let me switch pens here. If this continues, I'm going to have to switch out pencils. All right, let me switch out pencils. Okay? P is equal to our real power, our total power, which is 47.7 times our power factor, which is 0.662. Just like that. So now our P value is 47.7 multiplied by 0.662, roughly about a third, so 31.58 watts. That's our real power. This is our total power. This is our power factor. Now, please recheck my math and comment in the comment sections. Obviously, if you make a slight error here, it'll cost you the entire problem. So we want to make sure all our calculations are absolutely correct. Okay. For the next step, for part 4 of the video, we're going to do our energy bill calculation.